Hi everyone, this lesson is for geometry CPM students. This is chapter 3 review for your test, and it's a last minute Lucy, which means that it's also on Canvas. So you watch the video here, then do the work on Canvas, and they're similar problems. So good luck, and let's get started. So first question says, what's the value of x in the proportion? So we are going to cross multiply to solve. So we're going to say 21 times x plus 1 is equal to 15 times x plus 3. We can distribute, and by distributing each one, we're going to get 21x plus 21 equals 15x plus 15 times 3, which is 45. We're going to subtract 15 from both sides, 15x's. So subtract 15x's from both sides, and we're going to get 6x's. I'm going to subtract 21 from both sides, and I get 6x equals 24. And so x is going to equal 24 divided by 6, which is 4. Put your answers in solution set because that is a solution, and that's how you write the answer. And if you're a box person and I need to put this in a box. I mean, you can box up the whole equation, but make sure your answer is in solution set. The interior angles of a triangle are in ratio of 7 to 11 to 12. What are the angles? So you just draw a makeshift triangle. Remember, these are ratio of angles. So this is going to be 7 of something, 11 of something, and 12 of something, and that we know that the sum of the angles, if they're in ratio, they're of something. We don't know what the ratio is. So we're going to say 7x plus 11x's plus 12x's is going to equal 180. And yes, I'm totally fine with you guys using your calculators. And let's see, we've got 7 plus 11 plus 12. What is that? 30. And we're going to take 30x's and we're going to divide that into 180. So x is equal to 180 divided by 30. And let's just do it like that. Cancel, right? These cancel. 30 on the left. These cancel with each other, make 1. 3 divides into 18 6 times, so x is equal to 6. Now, that's not necessarily the answer. So even though, yes, we did get x, they're not asking that. They're asking what are the values of the angles. And so you would say, well, this angle here, which is 7x, is going to be 7 times 6. And so that angle is 42 degrees. This angle is going to be 12 times 6, which is going to be 72 degrees. And this one will be 11 times 6, which is 66 degrees. And you can also add these up, right? 66 plus 42 plus 72 should add up to be 180 to check your work. For this problem here, it says use the graph below to find what AD to AB is. And so AD is this long length all the way from here to here. And it looks like AD, so you would say AD over AB. Okay, so AD is 8 plus 1. This looks like it must be 9. And so that's going to be 9 to AB, which is 1, 2, 3. So 9 to 3, you're going to keep that in a ratio because they are asking you what the ratio is. And so you would say, if I divide both of these by 3, I'm going to get 3 over 1. Another option for writing it like that is you can write it as 3 dot dot 1 or 3, 2, 1. For this problem here, we want to know a ratio that goes from the slope of BE. So the slope for BE is this line right there. And they want that in ratio to the slope from A to E. So slopes are rise over run, and there's 2 ways to do this. Okay, so one way of doing this is actually calculating the point. So this looks like 4, 5. So this point is 4, 5. And this point is 3, 0, and this point is 0, 0. So if I'm finding the ratio of 2 slopes, so I'm going to start with BE because that's what's on top. So you've got the slope of segment BE, okay? And then you've got the slope of segment AE. Slope is rise over run. So we know that I could do this, and I could say the rise, which is up, straight up, right? Up 5 over 1. Up 5 over 1, right? My slope is 5 over 1, which is 5. And my slope, and another option is to subtract your y's over subtract your x's, right? So you would say 5 minus 1. So slope, remember, is the change in y over the change in x. So you can go subtracting your y's is a formula. y2 minus y1 over x2 minus x1. And so that would give me 5 minus 0. So I see I'm subtracting my y's. 5 minus 0 over 4 minus 3, which is still 5 over 1. So, you have to decide how you want to, solve that. For the second problem also is just a rise over run. So I'm going to go up 5, but for this problem, I'm actually going over 1, 2, 3, 4. So the slope for AE is 5 over 4, whereas the slope for BE is just 5 over 1, right? So realistically, if I was rewriting this, because this means divide, I can say 5 over 1, or just 5, divided by 5 over 4 becomes 5 times 4 over 5, right? Cancel the 5s, they become 1, and I have 4 times 1, which is 4. So the ratio of BE to AE is going to be 4 to 1, and then you would write it like that. The next problem says the measure of two complementary angles. So remember, complementary angles are two angles that add up to be 90 degrees. And so they're in ratio of 2 to 3, which is meaning 2 of something and 3 of something. So they want the measure of the smaller angle, which will be the 2 of something. Meanwhile, we have to set up an equation. So we have 2x plus 3x. So this angle plus this angle add up to be 90 degrees. I get 5x is equal to 90 degrees, and x is equal to 90 degrees divided by 5. So I'm going to just use your calculators, totally fine. 1, 4, right? 5 goes into 40 8 times. This makes 18. Now keep in mind that this answer is not, that's just x. That's not the actual answer. So whatever the value is, this is degrees. So this is going to be 2 times 18, which is 36 degrees. That's my answer for the smaller one, right? And then if I wanted the larger one, I just say 18 times 3, or I could say 90 minus 36. But they didn't ask that. They just wanted the smaller angle. For this problem, this is a true-false. Determine whether the polygons are similar. It says an equilateral triangle. So an equilateral triangle means all sides are congruent. This side is the same as that, is same as that. The side length is 6. Well, okay, all 6s. So determine whether the polygons are similar. And another equilateral triangle with side lengths of 15. So 15 here, 15 here, and 15 here. So two things. Number one, we have side, 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 right? And notice that if these two triangles are similar, then the ratio all the way around is going to be the same. So 6 is to 15, right? This side is to this side. Is the same thing as 6 is to 15, as that side is to that side, and likewise the last side, okay? And I know it's not reduced, but that's not the point. The point is, if these two triangles are similar by side, 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 similarity theorem, then all the sides have to be proportional, which they are. So check, we have that. Additionally, we also know that if it is an equilateral triangle, all the angles are 60 degrees. And for you to have two triangles that are similar, the one requirement regarding angles is that all angles are congruent. So angles are all congruent in similar triangles. So that means that we also have the angle-angle similarity postulate, which says that the two angles plus the third one is congruent. So they are congruent. So this is a true, basically for that reason. This is a true-false again. Determine whether the polygons are similar. So we have a triangle, and it looks like a 3, 4, 5, which hopefully you understand is a right triangle from Pythagorean are triplets, 3 and then 4 and then 5. And it says, in a triangle with side lengths of 18, 19, and 20, so we have 18, 19, and 20, 20 being the longest side, because if this is a right angle, that has to be a right angle here, because for them to be similar, not only do you have to have the angle, because not all right triangles are similar. Okay, keep that in mind. You could have this right triangle, which is a 45, 45, 90, and then you could have this right triangle, which is a 30, 60, 90, definitely a right triangle, both right triangles, but definitely not similar. Okay, so you've got to be careful. Not all right triangles are similar. So what we needed to understand is that this looks like if these are similar, they have to have a common ratio, first of all. So that means that 3 is to 18. So I'm going to reduce that. That's just 1 is to 6. Has to be in a ratio as 4 is to 19. Not happening. That didn't happen. And also, it has to be in ratio of 5 to 20, which also is 1/4, and that's also not similar. So this would be definitely a not. These two triangles are not similar. To find the value of y and also give this scale factor. So we know that starting with A, right here, A, see how it goes A? A has to correspond with T. So they drew this wrong. So, I mean, they didn't draw it wrong. They just gave it to you incorrectly. So we're going to redraw this, because the first thing that you need to remember is that when you are creating similar polygons, that the angles have to match up. A has to be congruent to T. So that means T has to be here. B, being here, has to be congruent to S. So that has to be S. C, which is down here, has to be congruent to V. And then the last one would have to be U. So I know that UV is 25.5. I know TU, which is over here, is actually this side, which is 3y plus 6. ST is 25.5. And SV is 3y plus 6. So your job is, now that we're done with this, I'm just going to cross this out because that's gone. We are not referring to that anymore now that we've redrawn our shapes. So to find y, first I need the scale factor, and I have to find two sides that are congruent. And it looks like 17, not two sides that are congruent, but two sides that are in ratio. So I have 17 to 25.5. So that's my scale factor. So I'm going to go 17 is to 25.5 as, now I'm trying to find y, so I can say as this side is to this side. So I'm going to go 3y minus 3.5 is to 3y plus 6. And so now I'm going to cross multiply, and I'm going to say 17 times 3y plus 6. So I'm going to go this right here times this is equal to the other side. So I'm going to multiply 25.5, okay, is equal to 25.5 times this length here. So those have to equal. So 3y minus 3.5. Okay, and this is 17. So I'm going to just multiply, right? And I've got 17 times 3, and that's 51. And so we have 51y plus 17 times 6, so that's just double 51, which is 102, is equal to 25.5 times 3, which is 76, 3y, 76.5y, and this is minus 25.5 times 3.5. So 3.5, and that's 89.25, and that's minus. So that's 89, and I'm out of room. So let me move everything over a little bit. Minus, and then this is going to be minus 89.25. Okay, so now let's get our y's on the same side. So I'm actually going to take this 51 and move it to the right side over here. So I'm going to take 76. Let me get rid of this. I'm going to take 76.5. So 76.5 y, and I'm going to subtract 51 y's, and I get 25.5. So on this side, I get 25.5y. And on this side, see this negative 89? I'm going to move that to the left side, and that means I'm going to add that. So plus 89.25. So I've got 89.25 added to 102, and that gives me 191.25. So 191.25, and I just have to divide that by the 25.5. So divide that by 25.5. And I get y equals 191.25 divided by 25.5, and I get 7.5. So y is equal to 7.5. This is a solution. So put that in a solution set, and we're done. The next problem says MNOP to QRST. So if I wanted to just kind of visualize what this might look like, I'm going to draw it out, right? So here's M, here's N, here's O, and here's P. And remember, because they are similar, whatever M is, Q has to equal. So that means Q is going to be up here. And then N is going to correspond with R. So that's going to be R, and then S, and then T. So now we know that the scale factor is 5 to 4. So actually, it should be large to small. So what I'm going to do, I think, is shrink that. I'm going to shrink that. And fix that a little bit because I want to make sure it's just accurate. And so we have M, this was N, this is O, and that's P. And then this was Q, there's R, here's S, and here's T. And the reason I shrunk that is because it's large to small, and I didn't read that ahead of time. So anyway, MP is 85, so that's this value right here. We want to know the value of QT. So all you have to do is set your ratio, and you're going to go 5:4 as 85 is to x. So we cross multiply, we get 5x equals 4 times 85. And so x is going to equal 4 times 85 and then divided by 5. So I'm going to go 85 times 4 equals, and that equals 340. And I'm going to divide that by 5, and I now have 68. So x has a value of 68. Okay. The next problem says PRQ is similar to DEF. Find the scale factor. Oh, and also, we already know that they're similar. So therefore, I don't have to check to see if they're similar. So what I do want to do is see how it goes P and then left R. I want to rewrite this. So this is going to go D up here, and then it's going to go left E. So here's E. And then over this way is going to be F, and then we're going to connect those because you have to have them the same direction and they have to correspond. So if it's going to help you and always to redraw them, please just do that. We know that DF is 24, so that goes here. We know angle E is 35, so that goes here, which means that F should be congruent to Q, and so that those are 89, etc. All right, so I am done with this triangle. Or I'm going to cross that out because I'm not going to reference that anymore. And so what they want to know is the scale factor. I can't go 40 to any value because there's no value for ED, so we don't use that one. And I can't go 36 is to any value down here because we don't have that value, so we're not going to use 36. So the only two values that I actually have are 20 and 24. So then my scale factor would be 20 to 24. And then I would reduce that. I'm going to reduce this by 4. And so on top I get 5, and on the denominator I get 6. So my scale factor is 5 to 6. So I could rewrite that different ways, like 5 to 6 or even 5 to 6. Just note that since my scale factor is 5 to 6, my ratio of perimeters is also 5 to 6. And my ratio of areas is going to be 25 to 36, because you take your scale factor, whatever that is, and you're going to square that, and that's going to give me the ratio of areas. For this slide here, it's asking me to find DE now. Now, I believe this is the same picture from the last slide, so I'm going to go back And I'm just going to, I think I'm going to take a screenshot of this really quick so I don't have to redraw it. And what I'm going to do is take this value here, because I already redrew it, and shrink that a little bit because you guys have that in your notes, so I don't have that. And so they want to know what DE is. And so this looks like this was D, and here's E. So they want this value here. So again, I'm going to get rid of this. And so in order to find DE, right, I'm going to use my scale factor. What was my scale factor? 5 to 6. So we're going to go 5 is to 6 as, right, we went 20 is to 24. That's my 5 is to 6. So 20 is to 24 as 40 is to x. So you go as 40 is to x. So I'm going to cross multiply. I get 5x is equal to 6 times 40. And then x is equal to 6 times 40 divided by 5. 5 divides into 40 8 times. 6 times 8 is 48. So that value is 48. So DE is equal to 48. Annie and Victoria, I've heard those names before, are standing next to a flagpole. So here's my flagpole, and blowing in the wind. Here it is, okay? And Annie notices that Victoria is 1.6 meters and her shadow. So let's see. Here's Victoria. Victoria, there you are. You are 1.6 meters. And your shadows are always on the ground, right? Unless you're Peter Pan, shadows are on the ground. And that's 1.2 meters. At the same time, Victoria notices that the shadow of the flagpole is 7.5 meters long. So here's 7.5. That's the shadow. How tall is the flagpole? So we're trying to find how tall this flagpole is. So it looks like we have right angles here. We have two ratios that are going to be, because of the height and this being two triangles, right? It's going to give us corresponding angles and all kinds of cool stuff, right? Because this is really this triangle. Let me see if I can draw this really well. Something like this, right? And so we want to make these two triangles from the end of Victoria's shadow, which goes from here. We know that this angle is the same in both triangles. We also have this angle the same, and then we have these little corresponding angles, right, that are also the same. So in order to figure out how tall the flagpole is, we're going to need to make a proportion. So what I'm going to do is I'm going to split up this little triangle here. So I'm going to look at Victoria, which is 1.6 here and 1.2. And so I'm going to say this side here to this side of this triangle, because remember, the big triangle goes all the way across. And so I'm going to add the two together. So 7.5 plus 1.2 is 8.7. So the long side right here is 8.7. So I'm going to go 1.2. This side is to this side of the triangle, right? I split them up. 1.2 is to 8.7 as the height is to the height, as 1.6 is to x. We're going to cross multiply. We get 1.2 times x is equal to 8.7 times 1.6. And so let's do that. I'm going to do 8.7 times 1.6, and I get 13.92. So 13.92 is equal to 1.2x. I'm going to take 13.92 and I'm going to divide by 1.2, and I get 11.6. So x is equal to 11.6. And so that's how tall it is. So what are we talking? Meters? So this is 11.6 meters. Okay, so this is it's equal to 11.6 meters. All right, cool. This problem says determine whether or not the triangles are similar. All right, now you are assuming, let's see, if so, write the similarity statement and find the ratio of areas. So let's see, if they're similar, then the sides are proportional. So meaning 5 is to 10. So height is to height, right? So 5 is to 10 as base 14 is to 28. And I'm guessing that you're seeing that they're both a half, right? Okay, so and I can cross multiply too and say 5 times 28 is equal to 10 times 14. And so we're going to get 140 on both sides. So yes, they are similar. The reason for them being similar is side angle side. And so that's something also you should know. Side angle side similarity, because I can't just have two sides that are proportional. I either have to have three sides, right? The side similarity, or I have to have at least two angles. But I don't see two angles. I only see one angle. So what I see though is side angle side. So that's my side angle side. And so even though you see a side angle and side doesn't mean that the two triangles are similar. You have to test the sides because the sides have to be proportional. And you could also just look here and say, well, that's 5 over 10, which is a half, is equal to a half. So number one, I know my scale factor is going to be 5 over 10, which reduces to 1 over 2. My ratio of perimeters, right, is going to be the same value. It's 1/2. But my ratio of areas is actually my scale factor squared, which is going to be 1/2 times 1/2, and that's going to be 1/4. So that's the answer to this problem. For this problem here, it's telling me that the lengths are similar. I want to find x. X is down here. I am going to split up these two triangles. I know not everybody likes to do that. I think it works better every time. So I am splitting this up. And in doing that, so we've got that. I'm going to put it down here. We've got that triangle. And then I'm going to redraw this just like that. And you can redraw it also. Okay, so putting in the values that we have, we know that this little side is 12 right here. We know the base is 17. And we know that the right side is 15. We also know that, what do we know? We know that's x. We know this left side here is 12 plus 8. Don't get confused with this x. That's not like a variable. We're not trying to find that. We know that that's xy. So 12 plus 8, which is 20. And this side over here is 10 plus 15, which is 25. So we're going to go, my scale factor, I can either use 12 is to 20 or 15 is to 25. Either one is going to be fine. So my scale factor is just, I'm using 12 is to 20. I'm going to divide by 4, and dividing by 4, I get 3 over 5. So that's my scale factor, which, by the way, is the same thing that I would have gotten if I had compared 15 to 25, right? If I divide by 5, I still get 3 over 5. All right, so to find x, to find the value of x, I'm going to use my scale factor, which is 3 to 5, and I'm going to go 3 is to 5, so left side is to right side, as left side is to right side, as 17 is to x. I'm going to cross multiply. I get 3x is equal to 17 times 5, and so x is going to equal 17 times 5 divided by 3. You can work that out. 17 times 5 equals, I've got 85. 85 divided by 3 is, let's see, what is that going to be? Approximately, it's 85 thirds, which is about 9.4. So you either write 9.4 about, or you can just write 85 over 3 is equal to x, and that's also correct. So either one is completely fine. For this problem here, again, we know that the triangles are similar because one angle here, one angle here. Also, these two angles are vertical angles. You have to have either two angles to have the two triangles similar. You have to have two sides in the included angle, or you have to have three sides that are proportional. And remember, the sides always have to be proportional. All right, so I'm going to redraw this. It goes L, right M, down N. So that means this is going to go P here. There's P. O to the right, and then down N. So, I mean, you need to redraw it. It's going to help you on the test, okay? they're telling you right here that L is congruent to P. This L is congruent to that P. So whatever those angles, they're the same. It also is saying M is congruent to O. So M and O, we already know that's congruent. Those are both right angles. And N is equal to N because it's the same angle. So N is equal to N. I'm not going to cross that out yet because I haven't taken all the information yet. I know that NO is 12, so I'm going to put 12 here. And OP is 14, and that's there. So now I'm going to cross these out because I want to find X. I want to find the value of X. So I'm going to find my scale factor, and my scale factor is 42 to 14, and that's large to small. That's my scale factor. I'm going to reduce by 7, and 42 divided by 7 is 6, and 14 divided by 7 is 2, which, by the way, I should have divided by 14. And so this is going to be 3 over 1. So my scale factor is 3. So that means that to find X, I'm going to go 3 is to 1. So that's 42 divided by 14 as X is to 12. And so I'm going to cross multiply. I get 1 times X is X, and that equals 3 times 12. So X is equal to 36. Put your answers in solution set. It is solving a problem. It looks like we have Eli here, and Eli places a mirror on the ground. There's the mirror, and 24 feet from the base of an oak tree. Okay, so this is my 24, and he walks backwards until he can see the top of the tree, and so now he's walking backwards. So now he can see like the top of that tree, right? From the base of the oak tree. He walks backwards in the middle of the mirror. At that point, Eli's eyes are 5.5 feet above the ground, and his feet are 4 feet from the mirror. How tall is the oak tree? So 2 things you can do. You ought to be able to see that you have a triangle right here, and you also have a triangle right here. All right, and you're trying to find X. This is X. So again, I mean, I sound like a broken record. I know that. But I would always redraw the triangle. So here's Eli. Here's his baseball hat. He is 5.5 feet, and the base here is 4. And, you know, he's standing up tall, so that's going to be a right angle just like a tree. So you're going to make a proportion, and you're going to say, to find X, you're going to go 4, the base is to the base. So you're going to say 4 is to 24 as, for base, the small to large, as 5.5 is to X. We're going to cross multiply. We get 4X is equal to 24 times 5.5. So let's do that. So I'm going to go 24 times 5.5, and that's going to be 132. So I have 132 is equal to 4X. I'm going to divide by 4, and I get 33. All right? Looks like it. X is equal to 33. And so that's how tall the tree is. And it looks like we're in feet. So this is 33 feet. Okay. This question says, which of the following statements is false about any 2 regular pentagons? Regular pentagons are like, they have all the sides are congruent, all the angles are congruent. So regular means that are they the same? Do they have the same perimeter? Do they have the same number of sides? Are they going to be similar? It says which one is false. They have corresponding interior angles that are congruent. So what we do know is that, number 1, 2 regular pentagons, we're not saying that they're congruent. We're just saying that they can be similar, because like if I have let's say I have this shape is a hexagon, okay? And what I could do is basically, if I redraw this hexagon, right? Okay, let's think about this. Here's my hexagon again. There's another one, all right? And for this hexagon here, okay, I've got 2 hexagons. I've got this one, and I've got this one, which I'm going to make bigger, okay? So it didn't say that they were the same. It just says that they're regular. And regular means that all the sides are congruent, right? These are all the sides, they're congruent. Are all the sides congruent? This is not congruent to this. These are larger. But when I make them bigger, those sides then are congruent. So would that mean that they have the same perimeter? No. They still have the same number of sides, yes. They have to be similar because why? They all have the same angles. They have to have the same angles. And this is a, 1, 2, 3, 4, 5 hexagon, which means that each angle has 120 degrees, right? Because if you take 720 and divide it by 6, that's going to be 120. So they have to be similar, and they have to have all of the interior angles have to be congruent. Because anytime you have two similar shapes, and polygons are similar if you make them bigger and smaller, but they're not going to have the same perimeter. So that's a false. Two right triangles are similar. So they're telling me that they're already similar. All right. So I'm going to make one smaller and one larger. And it says that the area of the first triangle is x squared. Well, for area, remember area is equal to 1/2 the base times the height, where the base and the height are perpendicular. So the area of the first shape is x squared. And the area for the second shape, for this shape, is 4x squared. If the hypotenuse of the first triangle has a length of 14, then what is the length of the hypotenuse of the second triangle? This is a great question. Because what you're thinking of is this. You need a scale factor. And remember, though, we do know the scale factor if we have the ratio of areas, right? The ratio of areas is my scale factor squared. So all I have to do is set up my scale factor, which I know the ratio of areas is going to be x squared to 4x squared, right? And my x squareds are actually going to cancel out because those are the same value, 1. So I know that the ratio of areas is 1/4. So to figure out what my scale factor is, if to undo that, right, all I have to do is square root that, and that's going to be the square root of 1 over the square root of 4, which is 1/2. So my scale factor is 1/2. So I'm going to go 1:2. That's my scale factor, as 14 is to x. And I'm going to cross multiply. 1 times x is x, and 2 times 14 is 28. So x, my hypotenuse, has got to be 28 units. All right, right on. Cool. Okay, so the midpoints of two sides of a triangle are connected. So here's our triangle. Now, if the midpoints here and here, let's say, are connected by a line segment, a smaller triangle is formed. Check. Which theorem or postulate does it immediately follow that the two triangles are similar? Well, it has to be the angle similarity, because once you have the mid-segments connected, that's going to be parallel to the base. It also means that that's congruent to that because those are corresponding angles. This also corresponding angle. So now at least I have two angles in different triangles, plus this angle at the top. So obviously 3 angles are congruent to 3 angles. So therefore, the angle similarity postulate is going to show that these two triangles are similar. And lastly, we have 2 equilateral triangles. And so we have equilateral triangles. It didn't say that they were the same, but it does say that the ratio, I'm looking ahead, is 2:3, so small to large, okay? What is the ratio of areas of the 2 equilateral triangles? So again, my scale factor is 2:3. My ratio of perimeters is the same value, and that's also 2:3 is the ratio of perimeters. But my ratio of areas is going to be my scale factor, which is 2:3, quantity squared. And so that's actually 2/3 times 2/3, which is 4/9. And so the ratio of areas is 4/9. Cool. So good luck on your Chapter 3 test. That concludes our last minute Lucy review. I wish you the best, and thanks for watching.